Hey, student, how are you? Welcome to our session on solving logarithmic equations. We're going to do 5 problems. First one, I'm going to use this equivalency. Log base b of y is equal to x is equivalent to the exponential form. B to the power of x is equal to y. Letter A. We'll start by isolating the logarithm. We'll divide by 3. And we're left with log base 5 of x. Base 5 of x is equal to 3. And now we can rewrite this using exponential form. Log base 5, so 5 raised to the power of 3 is equal to x. And 5 to the third power is 125. Number B. We'll isolate the logarithm by subtracting 2 from both sides of the equal sign. And we're left with common log, or log base 10 of 4x is equal to 1. And this is common log. Common log is log base 10. And we'll raise it to the first power, and that's equal to 4x. So we get 10 divided by 4, which reduces to 5/2. Letter C. The logarithm is already isolated, and this is natural log, log base e. So we'll do e raised to the 7th power, writing in exponential form. And then we'll subtract 6. And you can always put this into the calculator and get a decimal equivalent. Number 2. Number 2, we've got log base 3 and log base 3 on both sides. So I'm going to do 3 to the power of log base 3 of 5x. And 3 raised to the power of log base 3 will cancel out and leave us with just 5x. And we'll do the same thing on the other side. 3 raised to the power of log base 3 cancels out. We're left with 2x plus 9. And then we'll subtract 2x and divide by 3. Number B, we'll start by adding to bring log of 7x minus 8 to the other side of the equal sign. And now we can do 10 raised to the power of common log, or log base 10. And that'll cancel out, and we're left with 5x plus 2. And what we do to one side, we have to do to the other. So 10 raised to the power of log base 10 cancels out. And we're left with the argument, 7x minus 8. And then we'll add 8, bring it over to the other side, and subtract 5x. Divide by 2. Number 3, using properties of logarithms to condense. Letter A, we'll use the product property. When you're adding two logarithms with the same base, you can rewrite it by multiplying the arguments together under one log. So we get log of 5 times x is equal to 2. And then we can rewrite this using our exponential form. This is common log, log base 10, raised to the second power is equal to 5x. And we get 100 is equal to 5x. Divide by 5. Number B. Subtraction, we'll use our quotient property of logarithms and rewrite this using division, x divided by 3. Log base 2 of x divided by 3 is equal to 1. And then we can rewrite this using exponential form. Log base 2, so 2 is our base, raised to the first power, 1 is our exponent, is equal to x divided by 3. And we get 2 is equal to x divided by 3. We'll multiply by 3. Continuing to use properties of logarithms, we'll do a couple more. Letter C, we've got subtraction of natural log, so we can rewrite this as natural log using our quotient property of logarithms. We can rewrite the arguments in division. Equals natural log of 5. And now we've got natural log isolated on both sides. So if we do e to the power of natural log, that'll cancel out. And we're left with x minus 3 over x minus 5 equals, and what we do to one side, we do to the other. So we'll raise e to the power of natural log of 5, and we're left with 5. And then we'll multiply x minus 5 times 5, bring that over to the other side. We get x minus 3 is equal to 5 times x minus 5. We'll distribute 5. And then let's see, we'll get x's on the same side, subtract 5x, and then add 3. And let's see here, negative 22 divided by negative 4, we get positive 5.5. D. We've got the 2 as the coefficient on the outside of the log. We can use our power property of logarithms and raise x to the second power. We get log base 2, log base 7 of x raised to the second power equals log base 7 of 121. And now we could do 7 raised to the power of log base 7 cancels. 7 raised to the power of log base 7 cancels. And we're left with x squared equals 121. And we'll take the square root to undo the power of 2. And we get x is equal to positive 11. Number 4, 2 more. Number 4, let's take a look at one involving a quadratic. We can use the product property of logarithms and rewrite this addition of log base 3 of x plus log base 3 of x plus 8. We can multiply the arguments together. And now we'll rewrite this using exponential form. Base 3 raised to the power of 2 is equal to, and I'm going to distribute x times x and x times 8. And now I'm going to bring 9, subtract 9 to bring it over to the other side. 3 squared is 9. Now we've got a quadratic, so I'm going to factor. What multiplies to negative 9 adds to positive 8. And then we'll set each factor equal to 0, and we get negative 9 and positive 1. Now, we can't use negative 9. If you do log base 3 of negative 9, can't take the logarithm of a negative number. So our final answer is x equals 1. And the last one. Well, this property is really neat. You can square the base of the logarithm and square the argument of the logarithm, and they will be equivalent. And this will give us log base 4 of x plus 1 all squared is equal to log base 4 x plus 3. And now we can cancel out log base 4, and we're left with x plus 1 squared is equal to 3x plus 3. I'm going to square x plus 1, or FOIL it out. We get x squared plus 2x plus 1. And now I'm going to get 0 on this side. We'll subtract 3x and subtract 3. We get minus x and minus 2. And then we'll factor. What multiplies to negative 2 adds to negative 1. And we get x equals 2 and x equals negative 1. And both of these solutions are okay. We can put negative 1 into our logarithm. Negative 1 plus 1 is 0. So we're taking log base 2 of 0, not a negative. And that concludes our session on solving logarithmic equations. Thank you so much for joining our session, and I'll see you next time.